Okay, in this video I will be discussing how to solve rational equations. And these are just equations that contain one or more rational expressions, also known as fractions. So here's some examples, and you can see all of these equations have at least one fraction in them. And one of the things we'll focus on in most of our problems are equations where the fraction has a variable in it, in the denominator. And so let's go ahead and get started. The first thing we should talk about are least common multiples and how we find those. So it says to find the least common multiple for two algebraic expressions, we will do the following. Number one, we'll find the LCM of the numbers and identify any algebraic factors. And then step two, the LCM is going to be the product of the LCM of the numbers, that's what we found in part one, times each algebraic factor that we find to the highest power found. All right, so let me show you how this works. So on number one, we're finding the LCM of 3 and 4. So probably the most basic way people do this is just write out the multiples of 3. I've done 3, 6, 9, 12, 15. And the multiples of 4, we'll do 4, 8, 12, and 16. And you can see that 12 is the smallest, and so our LCM is 12. And in fact, if I kept going, 24 is also a multiple of 3 and 4. But again, we're looking for the smallest. When we start solving equations, we're going to want to use the smallest the smallest common multiple just to keep the numbers nicer. So that's why we tend to go with the least common multiple. Now I do want to mention one thing here. I normally don't do it quite this way. I have a little bit of an adjustment to this approach. I would just look at the multiples of the bigger number, which in this case would be 4, until I found one that was divisible by the other number, which in this case is 3. So notice 4 is not divisible by 3, and neither is 8. But when we get to 12, 12 is divisible by 3, which indicates that 12 is a multiple of 3. And so that's how I would normally find an LCM for two numbers. All right, so let's look at number 2. So we've got 4, 8, and x. So first of all, let's find the LCM of 4 and 8. And so I'll start with 8, or the multiples of 8, which are 8 and 16. But in fact, isn't 8 divisible by the other number 4? So 8 is a multiple of 4, and so 8 is our LCM. And we do have a variable factor of x that we need to include as well. So 8x is our LCM here. All right, on number 3, we're finding the LCM of 2x, 9, 18, and 3x. I would encourage you to try this and then watch the video. All right, so let's see how you did. So first of all, I want to find the LCM of 2, 9, 18, and 3. So I'll start with 18, and the multiples of 18 would be 18, 36, and I could go on. But in fact, if you look at 18, it is divisible by the other numbers, 2, 9, and 3. And so 18 is our LCM. And then we do have a variable factor, I'm sorry, I've called it an algebraic factor of x. And in both cases, they're to the first power, so it'll just be 18x here. Notice I don't multiply the two x's together to get x squared. I'm just using the smaller of the powers, and in this case, they're both 1. Now, if this had been 3x squared, then I would have used the highest power of x, which would have been 2, and our LCM would have been 18x squared. But that is not the case, so let me erase that. Let's move on to number 4. Now, in this case, you've got to be a little bit careful here. X plus 1 is actually going to be treated as a separate algebraic factor. The thing is, there's nothing here that you could factor out, and we would have a multiplication of two things. So we have to treat x plus 1 as a single number. Again, I call that an algebraic factor. And the same thing is true with x minus 3. Now, since I don't know what x is, I don't know what either of these numbers are. So the only way I could get a multiple of these two numbers would be to multiply them. And so our LCM is x plus 1 times x minus 3. All right, let's look at number 5. We're finding the LCM of 3x plus 6, x squared minus 4, and x plus 2. So for 3x plus 6, you'll notice we could factor out a 3. We get 3 times the quantity x plus 2. For x squared minus 4, that's a difference of squares, and we could factor that as x minus 2 times the quantity x plus 2. And so you can see that x plus 2 is a algebraic factor, as is x minus 2. And then notice we also have a numerical factor of 3. And so our LCM is just going to include the 3, our only numerical our only numerical number here, and then the two algebraic factors x minus 2 and x plus 2. All right, so on number 6, again, you may want to try it and then watch the video. Now you might be tempted here to multiply x minus 3 times x plus 3 times x squared minus 9. But in fact, doesn't x squared minus 9 factor? That's a difference of squares. We can write that as x minus 3 times x plus 3. So in fact, we only have two factors here, algebraic factors. That would be x minus 3 and x plus 3, and the product of those makes our LCM. All right, let's move on to the next slide. So on number 7, we have x plus 1 over 3 minus x minus 1 over 4 is equal to 1. And so for our denominators 3 and 4, we actually already found the LCM of 3 and 4, and that would be 12. So when we were solving equations, we talked about, I call it the CSI 1 and 2 step. The C is for clear fractions, which basically means you get rid of the fractions, and you do that by multiplying each term on both sides of the equation by the LCD, or the LCM of the denominators. So we're going to want to multiply each of them by 12, and let's go ahead and do that, and then we'll go from there. So notice for the first product here, 12 divided 3 is 4, and we're left with 4 times x plus 1. And then notice for when you multiply times 12 on the second term here, 12 divided 4 is 3, and you're left with minus 3 times x minus 1. And then on the other side you have 12. All right, so that's the C, clear fractions, we've done that. And then S was for simplify, and in fact we do have some simplifying we can do here. So we can distribute the 4, we'll get 4x plus 4, and then we'll distribute the minus 3, we'll get minus 3x plus 3. On the other side we have 12, so that's equal to 12. We're still not done simplifying because we can combine our x terms. 4x minus 3x is going to give us a 1x, and we can combine the 4 and 3 to get plus 7. So x plus 7 is equal to 12. We'll subtract 7 on both sides, and we get x equals 5. So notice I didn't have to do the I step where you try to isolate x on one side. We never had x on both sides, so that wasn't an issue. All right, let's move on to number 8. Now in this problem, we have x squared over x minus 5 is equal to 25 over x minus 5. So x minus 5 is our only denominator. That's going to be our LCD. So let's go ahead and multiply each side by x minus 5. So on the left, our x minus 5's cancel, and you're left with x squared. On the right, our x minus 5's cancel, and you're left with 25. And by the way, you saw how I put those little ones in there. We're really just dividing the numerator and denominator by a common number, and you would just get 1. So it's really 1 times x squared. So that's another way. For some people, having those ones there can be quite helpful. But we don't always put them in. So we have x squared equals 25, and I'm going to go ahead and use the square root method. and take the square root of both sides. And so we have the square root of x squared, of course, is x. And remember, you got to do that plus or minus thing on the right side, and so we get plus or minus 5. And I'm going to go ahead and write the two answers out separately, negative 5 and 5. And I want you to look at those answers and think about if there's any problem in terms of those being a solution to this equation. So if you look at our denominator, it's x minus 5. What if you plug in 5 there for x? 5 minus 5 is 0. You would have a fraction with a denominator of 0. That makes the fraction undefined. So x cannot be 5. We actually call this a restricted value. And so we actually only have one answer here that works, and that would be negative 5. So we normally cross off the other answer, and notice I've circled or squared the correct answer here, the one answer we have. All right, so here's our steps for solving rational equations. Number 1, we're going to list any restrictions. Number 2, we'll find the LCD of the denominators, and then we know we're going to use that to clear fractions. That's step 3. And then step 4, we'll solve the equation that we get after we clear fractions. And then in the end, you just want to make sure you throw out any restricted values that come up as solutions. Like in the last problem, 5 was a solution, but it also was a restricted value, and so we had to throw it out. It doesn't actually, it's a solution that we got, but when you plug it into the equation, it doesn't actually work. And this does happen at times. So we've got to check at the very end. All right, so let's move on to the next slide. All right, so on number 9, we've got to find the LCD of x, 8, and 4. And again, you'll see that we've already found these LCDs. Here it would be 8x. And again, we did that on the first slide. So we're going to multiply each term by 8x, and we're going to list our restricted value. X cannot be 0. Notice if x were 0 here, we would be undefined. So we do have one restricted value. Let's go ahead and multiply everything by 8x. When you multiply 1 over x by 8x, the x's are going to cancel, and you're left with 8 times 1. On the other side, when you multiply 8x times 1 over 8, the 8's will cancel, and you're left with x times 1, or just x. And then we have minus 3/4 times 8x. Well, notice 8 divided 4 is 2, and we're left with negative 3 times 2x, or minus 6x. So we've cleared the fractions. Notice here we're going to want to simplify next. X minus 6x is negative 5x, and that's equal to 8. And then we'll divide each side by negative 5, and we get x is equal to negative 8/5. And so notice 0 was our restricted value, and that's not one of the answers we got, or one and only answer that we got. And so we're good. All right, so I'd encourage you to try maybe the next 2 problems, or maybe even all 3, and then watch the video. All right, so on number 10, our LCD here is going to be 18 and also x, so 18x, and so we're going to multiply each term by 18x, and again, notice x can't be 0 because if x were 0, then we would have a problem here. 2 times 0 would be 0. Or in the other denominator where we have a 3x, 3 times 0 would be 0. So that's our only restricted value for x. Let's go ahead and multiply each term by 18x. So we have 18x times 5 over 2x. We can divide 18 by 2 and we get 9. And notice also the x's cancel. And so 9 times 5 is 45. And then notice 18x over 9, the 18 divided 9 gives us 2. And we're left with 2x times 8. We're going to get a minus 16x there. Notice the minus. On the other side, we're multiplying 18x times 1 over 18. The 18's cancel, and we're left with 1x. And 18x over 3x, you can divide 18 by 3. You're going to be left with 6 times 1. So we get minus 6. Notice the x is also canceled there. And so we have 45 minus 16x is equal to x minus 6. All right, so let's see. We need to get x on one side only. Everything's been simplified on both sides, or there's nothing to simplify on each side. We don't have any like terms here. Okay, so let's why don't we add 16x to both sides? We could also subtract x on both sides. Either way would work. So we get 45 is equal to 17x minus 6. Let's go ahead and add 6 to both sides. We're going to get 17x equals 51. And if we divide each side by 17, we get our final answer of 3. Notice our restricted value was 0. And so we're okay here. We can stop right there. That's a good answer. All right, I'm going to go ahead and stop the video here, and I'll make a second part.